Aloha, my name is Robert from Naepapakahana, and welcome back to the Canoe Project Online Professional Development. Today we'll be talking about Module 4 of 15. So to begin, let's go ahead and go back to our website, www.stemd2.com. That's www.stemd2.com. After you've logged in, let's go ahead and go up to Students, and let's build a canoe. Today we'll be covering Module 4, which is in Unit 2 of the Go Math book. So we're going to go down to Unit 2. Now we're going to go down to Module 4. Here are the activities for Module 4, which covers non-proportional relationships. These are relationships that are linear but have a non-zero y-intercept. The first activity we'll be covering is Canoe 4.2.1. This is the first activity that corresponds with Lesson 4.2 in the Go Math book. In this activity, we'll be learning about the Molokai Hoe, a 41-mile race from Molokai to Oahu. We'll be looking at 3 canoe teams in this race. The first canoe team that we'll be looking at is Lolo Uncle. This team consists of a bunch of irresponsible uncles. The uncles on this team, they accidentally went to the wrong dock at the start of the race. So they actually started 28 miles away. The function that describes the position y with respect to the time x is given by this. There's also another team called EDT VA, and this team finishes the 41-mile race in 4.8 hours. With this information, we can find the equation that relates the position of EDT VA and the time during the race. Finally, there is one more team called On Time Ante. The paddlers in this team, they start the race on time and they paddle at a rate of 9 miles per hour. With this information, we can also write an equation that describes the position of On Time Ante over time. After we have the 3 equations, we can organize the equations and fill out this table. So we can talk about the y-intercept or the initial position of the 3 teams. We can also talk about the speed of the 3 teams, which is the rate or the slope. After we've organized the information about the 3 teams, we can try to figure out what place did they finish in. Once again, we can answer in LaTeX, but we don't have to. If you want to talk about the initial position of Uncle Lolo, we can type in B sub 2 equals negative 28. And the students type this and submit this here, you as a teacher will see this. Alright, that's it for this activity. Please go ahead and pause the video and review and reflect on it. Aloha, welcome back. The next activity we'll be looking at is Canoe 4.3.2. This is the second activity that corresponds with Lesson 4.3 in the Go Math book. In this activity, we'll be graphing 4 line equations, and then we will interpret the lines, and then we will interpret their points of intersection. Over here, we have a number line that's drawn along the west coast of Oahu. So the numbers on this line represent different positions along the west coast of Oahu. Along this coast, we also have 4 canoe clubs that paddle up and down the coast. So we have Club Ma'ili, Club Nanakuli, Club Ko'olina, and Club Ka'ena. Their position y at time t are given by these equations. What we want to know is when and where do these canoes meet, if they meet at all. And this can be done by first graphing the equation and looking for the points of intersection. Of course, we don't expect the students to be able to solve the equations yet, that is covered in Module 3, but we want to do this activity because we want the kids to get used to the idea of points of intersection and start to get comfortable with what they actually mean in real life. Alright, that's it for this activity. Please go ahead and pause the video and take some time to review and reflect on it. Aloha, welcome back. The next activity we'll be talking about is Canoe 4.4.1. In this activity, we'll be looking at the Hawaiian waters around Kauai. So as we can see from this map, Oahu is about 100 miles away from Kauai. Over here, we have 4 paths between Kauai and Oahu drawn. Path A is a straight path from Kauai straight to Oahu. Path B is a path straight from Oahu to Kauai. Path C is a path from Oahu going out into the water passing Kauai. And path D is a circular path starting and ending in Oahu with Kauai in the middle. What we want to do in this activity is to draw a graph of the distance from Kauai versus the distance traveled. So we have distance from Kauai being the dependent variable, and it's going to depend on the distance traveled. So for example, path C, as the distance traveled increases, we come close to Kauai and then far from Kauai again. So we should have some kind of curved graph that represents path C. So please go ahead and pause the video and read and reflect on this activity. Before you resume the video, please also try activity 4.4.2. This is a very similar activity, and it helps to do them one after another. Alright, that's it for Module 4. We'll see you later for Module 5.